Hello students, welcome to the course Exploratory Data Analysis for Data Science with R software. So in this lecture, we are going to continue with our concept of correlation coefficient. If you remember, in the last two lectures, we had talked about the correlation coefficient also, but that was the correlation coefficient for the continuous data. Now in this lecture, we are going to talk about the correlation coefficient when our data is the ranked data. What do you really mean by ranked data? Have you ever seen a fashion show where somebody comes on the stage and there are say couple of people as judges, and those suppose there are two judges and those two judges give them some marks. And how these marks are given? They want to actually judge. So based on their some performance or whatever are the characteristics, they will give them some scores. Now, what do you expect? If the candidate is doing a good job, then both the judges should give a higher score or a higher rank. And in case if the person is not doing so well, then both the judges are going to give the lower marks or the lower ranks. But if you try to understand what happened in the real life, those two judges are not consulting with each other. So it is possible, suppose somebody is doing very good, one judge gives the rank say 9 and say other gives the 8 rank. And similarly, if somebody is doing bad, somebody gives the rank say here 3 or somebody gives the rank here 4. But if you try to see, they are quite or less matching. What will happen in case if the candidate is doing a good job, one just gives the rank 9 and other judge gives the rank say 3, then they are opposite. So that means there is no matching between the opinions of the two judges. So in order to judge whether the opinions of the two judges are matching or not with respect to the ranks they have given to the candidates, we can use the concept of correlation coefficient and try to find out the correlation coefficient between these ranks. And this will also give us a fair idea that how the opinions of two judges are matching. The same thing happens when somebody is trying to cook some food in some show, and there are two judges which try to taste the food and try to give some scores. Based on that, they try to get the ranks. So if the ranks are given by the two judges are matching, that will indicate that the food was good and both judges feel the same. But in case if the ranks are opposite, that means the food was like that the two judges have different opinion. And ideally what we expect that if the candidate is good, then both the judges are going to give the higher ranks, and if the performance or the food or is not so good, then they will get the lower rank. So this is what we want to understand through the concept of rank correlation coefficient. So in this lecture, we are going to talk about the concept of rank correlation coefficient, and we will see how we can compute it in the R software. So let us begin our lecture and try to understand it. So now we are going to talk about Spearman's rank correlation coefficient. Actually, this rank correlation coefficient was given by Spearman, so it is called as Spearman's rank correlation coefficient. And you can recall that in the last lecture in the R command also there was one option, say Spearman, right? But in general, this is also called as rank correlation coefficient. So suppose if you have two variables x and y, on which you have got n observation on each of these x and y, right? Now these observations are actually ranked with respect to x and y. What does this mean? Suppose if a student gets a marks out of 100, something like here 40, the second student gets the marks suppose here 70, and third student get the mark here say here 10. So now if you try to give the rank here, so suppose if I say I give the say rank 1 to the student who has got the higher marks. So this S2 will be getting here rank 1, and then after that the student getting the marks 40 will be getting rank 2, and the student getting the marks 10 will be getting a rank 3. Right. So, this is what we mean by the ranks of the observations, right. So, we have got two sets of observations on x and y, and those observations are given the ranks. Now, we try to work on the ranks given by these two sets of data. Remember, we will not be working on the original values of the data, but we will be working, for example, here with the ranks of the data. We will not use here the data on here x, 40, 70 and 10, right. So, for example, as I gave you two examples. So, suppose there are n candidates who participate in a talent competition, and there are two judges who are judging their performance and are giving ranks to each of the participants, right. So, now suppose judge gives ranks to n candidate as rank 1 is given to the worst candidate with the lowest scores, right, say xi. Rank 2 is given to the candidate who has got the second lowest score, say xi, and finally the rank n is given to the best candidate which has got the highest scores, right. And similarly, the second judge y assigns the rank 1 to n candidates based on their scores y1, y2, y1, exactly in the same way the judge has given it. So, what will happen here, that every participant will receive two ranks, each assigned by the different judge. Something like this, if I say here participant, say number here 1, 2 up to here say here 10, and then there is here judge 1, and then there is here judge 2. Now, they give here a rank, say here 8, say 7, 2, and suppose here 5 and so on. Similarly, the judge 2 also gives the rank. So, if you try to see, these ranks are going to be integers, right. So, what do you expect from these two judges? We expect that if a candidate is good, then the higher ranks are given, and if the candidates are bad, then the lower ranks are given to the bad candidates. So, higher ranks to the good candidates and lower ranks to the bad candidates. And we want to measure the degree of association between these two different judgments. That means, two different sets of ranks. We want to find out the correlation coefficient between the two. Okay. So, for that we use the concept of rank correlation coefficient or Spearman's rank correlation coefficient. So, this rank correlation coefficient measures the degree of agreement between the ranks of two judges. And we use here the Spearman's rank correlation coefficient, which uses the ranks of the values and not the values themselves. This is very important to remember. Although when you try to do it in the R software, the R software will first determine the ranks and then it will compute it. So, you need to give only there the raw data, raw scores. So, now if I try to understand how to define it. So, if I say here rank of xi is the rank of ith observation on x, and it is something like all these values x1, x2, xn are ordered, right, and then out of them the ith observation getting the rank is recorded here as a rank of xi, and similarly here rank of yi is the rank of yth, say this ith observation on y. So, that means all the observations on y which are y1, y2, yn, they are ordered, and the ith observation yi, so rank is denoted as rank of yi. Then we try to find out the difference di by rank of xi minus rank of yi, and based on that the Spearman's rank correlation coefficient R is defined as here like this. R is equal to 1 minus 6 summation I goes from 1 to n di square divided by n into n square minus 1, right. And this Spearman rank correlation coefficient also lies between minus 1 and plus 1. One thing you have to keep in mind that it does not makes any difference, and it does not matter whether the ascending or descending order of ranks is used in the computation of this R here in this case, right. And the interpretation of this rank correlation coefficient, which lies between -1 and +1, is as follows. When both the judges assign exactly the same rank to all the candidates, then the value of rank correlation coefficient is +1. And if both the judges assign exactly the opposite rank to all the candidates, then R is equal to -1. And any value between this -1 and +1 will determine the sign and the magnitude of the degree of association between the ranks of the two judges. Okay, so let me try to give you here a very simple example to explain you what we are trying to do here. Suppose the two judges give a score to 5 candidates as follows. So judge 1 and here it is judge 2. So judge 1 gives the score here like this 75, 25, 35, 95 and here 50. So what we try to do, the minimum value here is 25, so we give it here the rank 1. After that, the next higher value is 35, so we give it here the rank 2. The third value in this increasing order is 50, so we get here the value here 3. After that, the fourth value here is 75, so we give here the rank 4, and the highest among all these values is 95, so we give it here a rank 5. Now, similarly, if I try to take the scores of judge number 2, then we see that out of this data, 30 is the minimum value, so it is given the rank 1. After this, the next higher order value is 40, which is given the rank 2. Then the next higher value is here 60, which is given the rank 3. Then after that, the second largest value is here 70, which is given the rank 4. And the highest value here is 80, which is given the rank 5. Right. So now we have got here, say here ranks of xi's here and rank of yi's here, and we try to find out their difference. So if you try to see here, here it will be 4 minus 4, right, 4 and 4, which is equal to here 0. Then in the next row it will be 1 and 5, so the difference of rank will be 1 minus 5, which is here minus 4. And similarly here other differences of the ranks are obtained. Right. Now, this is here your actually di. This is what you have to keep in mind. So, once I have got here the values of di, then I can use here the expression for this here, see here r, which is here rank of 1 minus something like 6 summation di square. This will be computed from here, and then n divided by n square minus 1. For this, n is equal to here 5 observations. So, this value will come out to be here minus 0.7. So, now if you try to see what does this actually mean, it is mean that the opinion of the judges 1 and 2 is opposite, and the degree of correlation here is 0.7, right. So, this is how you can interpret it. So, now if you want to compute the same value in the R software, then we are going to use here the same command, say here COR, which you have used to compute the simple correlation coefficient. Actually, if you try to see, if you try to look into the algebra of rank correlation coefficient, how this expression is obtained, then we simply try to use the same expression of correlation coefficient, and we use there the ranks as the data on x and y, and then we try to get this expression. So, that is why the command is the same COR, but we have to be careful here. In the COR command, if you try to remember, there were two data vectors x and y, and then use here there were several options, but after that an important option was method, where I have to use here a spearman within double quotes. That is a character string. So, once you try to use here the method equal to here is spearman, then you will get here this rank correlation, right. So, as I told you, use is an optional character string which gives us a method for computing the covariance in the presence of missing values. There are different options like everything, all dot ops, complete dot ops, na dot ops, or dot complete, pairwise dot complete dot obs, right. Now, I try to give here use here the same example, and I use here the exact scores only. I will not use here the ranks which we have obtained manually. So, these are the two judges which have got the scores from judge 1, scores from the judge 2, and now I am creating here two data sets, two data vector judge 1 and judge 2, and their data vectors are written here. Now, I try to use here the command here COR, X here is judge 1, Y here is judge 2, and then use here everything, and the method is equal to here say spearman. So, I can see here this value is coming out to be here minus 0.7. So, that is the same result which you had obtained there manually also, but let me try to show you this thing on the R console also, so that you get confidence about it. So, you can see here, you can use here this judge 1 and judge 2 data, and then you can use here this command here COR. So, you can get here this thing by minus 0.7, right. So, now you can see here it is very easy to compute this rank correlation, and basically you are going to use this correlation coefficient when the data is actually here ranked. But the main point here is that you see that when you are trying to use here the data in the R software, then you simply have to use here the only the scores, you do not have to give the here the ranks, right. So, now we conclude this lecture, and you can see here it was a short and very simple lecture, but the concept was very different. The concept is about the finding out the correlation coefficient between the ranks, and this type of situation many times occur in the data science, where you have got a big data and you want to know how people are feeling about it, particularly in the marketing area, what customer feels about it. So, you ask them to give them different scores, and you want to see that what different customers are feeling about it. If all the customers are feeling the same, that means that product has some issue or it is all good. So, depending on the values of this correlation coefficient, you can decide that how much is the opinion of customers is dependable to decide about the quality of a project, of a product or a service. So, that is how this race rank correlation coefficient is going to be very useful for you. So, as usual, my request to you is that please try to take some data and try to compute it. I will say that take a small data set and try to compute it manually also, so that you understand what are you trying to do, and then you try to use the R software, take a bigger data set and compute it and try to interpret it. So, you try to practice it, and I will see you in the next lecture. Till then, goodbye.